Now that we've completed looking at how to construct two proportion confidence intervals, I thought it might be useful to compare what we've seen in two proportion confidence intervals with what we also looked at back in Chapter 5 for constructing a confidence interval for a single proportion problem. So in comparing how we constructed a confidence interval for two proportions in section 6.2 with how we did that for a one proportion problem in Chapter 5, we're going to first of all look at the differences between the prepare steps. So in a one proportion problem, we identified the sample proportion as a point estimate and the sample size, and then we determined what confidence level to use. In comparison with that, for a two proportion confidence interval, we identified the sample proportion and sample size values for each of two samples, and then we computed a point estimate that consisted of the difference of the two sample proportions and determined a confidence level to use. Next, let's compare the check steps for both one proportion and two proportion confidence interval constructions. So with one proportion, we're checking to see if the sampling distribution of sample proportions based on a sample size of n from a population with a true proportion p is nearly normal. With the two proportion check step, we're checking to see if the sampling distribution for the difference of sample proportions based on respective sample sizes of N1 and N2 from populations with true proportions of P1 and P2 is nearly normal. Continuing on with comparing the check step, notice that for a one proportion check step, we looked for independence. That is, we wanted to make sure the sample's observations are independent. That is, that they are from a simple random sample, whereas when we did a two proportion check step, we had what was called the independence extended condition, in which we made sure the data are independent within and between the two groups. And in that case, that would be met by one of two ways: if the data came from two independent random samples, or if the data came from a randomized experiment. So concluding our comparison of the check step for both one proportion and two proportion constructions of confidence intervals, we take a look at the success failure condition for both. So for one proportion success failure condition check, we look to see if there are at least 10 successes and failures in the sample, and we use the sample proportion in place of the population proportion in the formula. For two proportion check step of the success failure condition, we check to see if there are at least 10 successes and failures in each of both groups. Next, let's compare the one proportion and two proportion calculate steps for constructing a confidence interval. When the check conditions hold, we calculate our standard error in very similar ways. So on the left, we see the formula for a one proportion case, and on the right, we see it looks like just an extended formula of the same thing that we have for the one proportion case. The only difference being that we have to take into account the fact that there are two populations at play. So there's a piece that has the first population proportion involved in the formula, and then the similar kind of formula with the second population proportion. In both of these formulas, we substitute sample proportions in place of the population proportions to perform our calculations. Continuing to compare one proportion and two proportion calculate steps, we notice that Z asterisk is found for both of those using the RGuru continuous distributions probability calculator. And then lastly, in comparing the two, we notice that for the one proportion calculate step, when we construct a confidence interval, the sample proportion axis is labeled as p hat. And for the two proportion calculate step, we notice that the difference of sample proportions axis is labeled as p1 hat minus p2 hat. Now, before concluding this presentation, it's worth pointing out that the conclude portion for difference of two proportions confidence interval, though similar to that of a single sample proportion confidence interval, differs in that we also take note of where 0 lies relative to the confidence interval.